All right, written problem 4, solutions for Math 112. I was pretty proud of this, not going to lie. I came up with this huge mess, and I think it simplifies really nicely. The answer should be 2, but knowing what the answer is doesn't really get you there. The idea of this problem is to show how this thing is equal to 2. So what you might notice is we have the log base 4 of 8 here at the start, and then log base 4 doesn't appear anywhere else in here. So we can kind of just deal with this part all on its own. 2 times the log base 4 of 8. Well, you might be able to figure out the log base 4 of 8 right off the bat and then multiply that by 2. But in case you can't, what you could do is you could use your third log rule to take this coefficient and bring it up into the exponent here. So you could recognize that this is really just asking you what is the log base 4 of 8 squared. And since 8 squared is 64, it just wants to know the log base 4 of 64. And 4 times 4 times 4 gives you 64, because 4 times 4 is 16, times 4 again gives you 64. So because 4 to the third power equals 64, the log base 4 of 64 is just equal to 3. And then this second term, which I'm going to change it so it just has 2 nested natural logs. Looks really ugly, but I think it's not as bad as maybe you think. The natural log of e, if I work from the inside out, is just asking me what power do I have to raise the base of e that's implied here up to make it equal to e. Well, this e to the first power would be this e, so the natural log of e is just 1. And so it's asking me this natural log of this 1. Well, the natural log of 1 is just asking me what power do I have to raise, again, the e up to make it equal to 1. And e to the 0 power is equal to 1. The log with any base of 1 is equal to 0. The natural log of 1 is just 0. Okay, what about this mess right here? 25 raised up to the power of the log base 5 of 1 over the square root of 3. What a mess. Well, yeah, but I think we can deal with it. If we had the base on this exponent matching the base in the log, things would cancel out really nicely. Unfortunately, we don't have that situation. But with the numbers we're given, I think we can rewrite it so that we have that situation. If you recognize that 25 is just 5 squared, you could rewrite this 25 as 5 squared and then raise that up to the log base 5 of 1 over the square root of 3. And we still can't cancel out this 5 and this 5, but now we can use one of our exponent rules. We have an exponent raised up to another exponent, and what we learned is that when you have exponents raised up to exponents, you can just multiply together those two exponents, and we can call this 5 raised up to the power of 2 times the log base 5 of 1 over the square root of 3. Still can't get rid of this 5 and this 5, but we're getting closer. If this 2 weren't here, we'd be in really good shape and things would cancel out nicely. Well, we can get rid of this 2 because it's a coefficient, and my third log rule says that I can move coefficients up into the exponent. And I can call this 5 raised up to the power of the log base 5 of 1 over the square root of 3 squared. And 1 over the square root of 3 squared is 1 squared over the square root of 3 squared, which is 1 over 3. So I have the log base 5 of 1/3. And you're like, surely I made a mistake because I don't know the log base 5 of 1/3. I don't know what power I can raise a 5 up to make it equal to 1/3. And I don't either, but there's good news. When the base of the exponent matches the base of the log, informally speaking, those guys cancel out and we're left with just 1/3. So even though we can't evaluate the log base 5 of 1/3, we do know that 5 raised up to that power that we can't evaluate is just equal to 1/3. I guess there's 2 terms left to deal with, but you might recognize that they're both log base 8. So maybe I can deal with them together. I don't know the log base 8 of 7/16, nor do I know the log base 8 of 7. However, I do recognize that since I have the same base and I'm subtracting these 2 logs, I can use my second log rule and rewrite this as the log base 8 of whatever 7/16 divided by 7 is equal to. And it's weird having fractions inside fractions, but I can deal with that if I change this 7 dividing 2 fractions, which is just like multiplying fractions, except you multiply by the reciprocal of the denominator. So I take this 7 over 1 and I flip it upside down. So I got 7/16 times 1/7, and 7/16 times 1/7 is just 1/16 because the 7's cancel each other out. Okay, then what is the log base 8 of 1/16? Well, I don't think that that's easy either. Probably the easiest way is to set this equal to x and then to rewrite it in exponential form and try to equate the bases so that you can solve for what the exponents are equal to. But let me try talking through without doing that. Let's see, I don't know what power I have to raise 8 up to make it 16. Forget the 1/16 for now. But I do recognize that 2 to the 4th power is 16 because 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 raised up to the 3rd power is 8, and 2 raised up to the 4th power is 16. So what I can do here is I can think about changing this 8 into a 2 by taking its cubed root, and then the cubed root of 8 to the 4th power would give me 16. To take its cubed root, I need a 3 in the denominator of the exponent. To raise it to the 4th power, I need a 4 in the numerator of the exponent. The problem is this isn't the right answer, because 8 to the 4/3 power is 16, not 1/16. But we can change it from 16 to 1/16 just by putting a negative here, because a negative exponent just means to take the reciprocal of it. What I'm saying is the log base 8 of 1/16 is negative 4/3. I think we've now figured out what each of these individual parts are equal to, so all we have to do is add up the 3, this 0, this 1/3, and this negative 4/3, and that'll give us our answer. Well, let's see, 1/3 and negative 4/3 is negative 3/3, which is negative 1. So I have 3 plus 0, which is just 3 minus 1. 3 minus 1 gives me 2, which was the answer that I was hoping or expecting to get, because it told me the answer up here was 2. But again, the idea is less about getting the answer and more showing where the answer comes from. And here's one way that you could show where the answer comes from.